instruction in LLVM has a pointer to its parent basic block, just as a basic block has a pointer to its parent function. And an instruction is a user, which will be explained below. And as expected, there are numerous functions for manipulating the list of instructions in a basic block. Also, there are interesting files such as instruction type, which are more general descriptions of an instruction, such as being a terminator instruction, a unary, binary, or comparison instruction. And then the real or concrete instructions, they are declared in this file. And there are, for instance, alloc A instruction. That's the name comes from the alloc A C function. Well, it's not the standard C, but it's a C function to allocate stack space. And this is for allocating memory to a temporary variable or to a variable. Okay, load instruction, store instruction, fence instruction, etc. Instructions have a type, and that's the type of the value that they produce. And this class is for the primitive types in C, such as float, double, void, and the integer types. And then there are the derived types for arrays and structs. Interesting is that to determine if two types objects are equal, then it's, I mean, if they represent the same type, then it's sufficient to compare the addresses of the objects, because the same type has only one instance. So a value represents what is computed, and both instructions and functions are values. And a value has a type, of course, and also a list of users of that value. And the users are also values. For example, an instruction can have an operand, and then this is the result of another instruction. Sometimes we want to go through, or sometimes we want to find the one which defines the value, and there is an explicit pointer to that, and at other times we want to go through all the users of a value. And to find the users of a value, the use type is used. So a user is something which can use a value as an operand. And as mentioned, a user is also a value. And an instruction is a user. And then there is a function called getOperand, which gives us a certain operand. And the use of a value is to connect a user and a value. And this is a very important object. So it's implemented in a way to be as efficient as possible. And as I mentioned, there is a direct pointer to the value that is used, and there is a special representation to find the different users of a value, and they can still be found efficiently. Here are some useful functions, and first, to get the iterators to the first and last basic blocks of a function, where f is a function, or actually, well, it's a function, it's a reference to a function. Functions are optimized in, if we optimize at the function level, we use function called run on function, which is declared like this. And it returns a boolean, and if the optimized function is modified, then it should return true, otherwise false. From F we get the first and last basic blocks, so we can iterate through all of them. And it's absolutely most convenient to ignore the type and just use the C++ auto like this. And once we have such an, and this is an iterator. So once we have an iterator, we can use begin and end on the iterator for the basic block to find or to get iterators of the instructions. And then when we have an iterator to an instruction, we can do various things with, I mean, it has this operator to get to the instruction. And one interesting function is this one, is identical to. So we have two iterators, and it's true if the instructions pointed to are identical. To see what it means that they are identical, we can read this. I mean, you can see in this file. And another is replace all uses with. And well, it does exactly what it says. So if we have an iterator to a certain instruction, we can call the instruction I for convenience. Then we can replace this, I mean the uses of this instruction, with another instruction using this one. And it's defined in this file. And to remove an instruction from a basic block, we use this one. Okay, and this one returns the next instruction after the removed one. If we want to move to the next instruction without removing, we can just use I++.